Factorizing quadratic expressions 1. We'll begin by looking at expanding brackets. Consider the bracket x plus a multiplied by the bracket x plus b. What do we get when we expand these brackets? X multiplied by x is x squared. X multiplied by plus a is plus ax. Plus b multiplied by x is plus bx. And plus a multiplied by plus b is plus ab. So there are the four parts of the expansion. We can collect the two middle terms in x together. So we get x squared plus, how many x's do we have? A plus b of them. And plus ab on the end. Now factorizing quadratic expressions is the reverse of this process. It's about taking an expression such as we have in the bottom line and writing it as one factor multiplied by another, one bracket multiplied by another. This will become clearer when we look at some examples. Example 1. X squared plus 5x plus 6. Now then, let's have a look back at our expansion of brackets. Notice that the number that goes in front of the x, the two numbers that are going in the back of the brackets have to add together to give the amount of x's we have. The two numbers at the back of the brackets have to multiply together to give the constant term on the end. So I'm looking for two numbers that multiply together to give plus 6 and add together to give plus 5. Right, well, let's begin by looking at the possible pairs of factors that multiply together to give 6. We could have plus 1 multiplied by plus 6. But equally, we could have two negatives. We could have minus 1 multiplied by minus 6. We could have plus 2 multiplied by plus 3. Or minus 2 multiplied by minus 3. And they're all the pairs of factors of plus 6. But notice only one of them adds together to give plus 5. So that's the pair that we want. And it means that x squared plus 5x plus 6 can be written as x plus 2 multiplied by x plus 3. We'll move on to look at further examples now. Example 2. X squared plus 11x plus 10. And we're going to write that as a bracket multiplied by a bracket. We'll have an x in each bracket. And we need to figure out what the numbers are that go in the brackets with the x's. Right. So I'm looking for two numbers that multiply to plus 10 and add together to give plus 11. Now you might spot this fairly quickly. Once you've found the correct pair, there's no need to go any further. But I'll just show you all the different pairs that it could be. We could be looking at plus 1 multiplied by plus 10. But minus 1 times minus 10 also gives you plus 10. We could have plus 2 multiplied by plus 5. Or minus 2 multiplied by minus 5. But we want the pair to also add together to give plus 11. And so it has to be plus 1 and plus 10. And that completes the factorization. Example 3. X squared minus 6x plus 8. Set up the brackets with an x in each bracket. Now we want two numbers that multiply together to give plus 8 and add together to give minus 6. So factors of plus 8. Plus 1 times plus 8. Minus 1 times minus 8. Plus 2 times plus 4. Minus 2 times minus 4. Trying to be systematic about identifying the factors. Start with 1 and work your way up until you meet yourself coming the other way. Obviously 3 doesn't go into 8, and by the time I tried 4, I've met myself coming the other way. So I'm confident I've got all the pairs of factors at plus 8. Which of those pairs of factors adds up to minus 6? Minus 2 minus 4. So that completes the factorization. X minus 2, x minus 4. A few more examples now, illustrating a different point. So we're looking at example 4, which is x squared plus 3x minus 10. Set up our brackets with an x in each. Now, why is this example different to the previous ones? Well, this time we're looking for a pair of factors that multiply together to give minus 10. So their signs will have to be opposite. I could have plus 1 multiplied by minus 10, but equally I could have minus 1 times plus 10, plus 2 times minus 5, or minus 2 times plus 5. So which of those pairs adds up to plus 3, the number in front of the x's? It's this last pair here. Minus 2 plus 5 comes to plus 3. So we can put minus 2 plus 5 in to complete the factorization. Another one similar to that, example 5. X squared minus x minus 12. Right, this time we want a pair of factors that multiply together to give minus 12. So we could have plus 1 times minus 12, minus 1 times plus 12, plus 2 times minus 6, minus 2 times plus 6, plus 3 times minus 4, minus 3 times plus 4. Now, what do we want this pair of factors to add up to? Well, let's see, we've got minus x, which means minus 1x. So I want a pair of factors that add up to minus 1. So that will be plus 3 minus 4. To give us the factors of x squared minus x minus 12. To complete this section, we'll look at two examples that use something called the difference of two squares. So let's first consider a plus b multiplied by a minus b. When we expand those brackets, we get a multiplied by a is a squared, a multiplied by plus b is plus ab, minus b multiplied by a is minus ab, and minus b times plus b is minus b squared. Now what we see here is the plus ab and the minus ab cancel out to give us a squared minus b squared. And that's what we call the difference of two squares. If we put a squared minus b squared, it factorizes into a plus b multiplied by a minus b. And we'll be using that in the next two examples. So example 6, x squared minus 25. So in this quadratic expression, there is no middle term, there's no term in x. But what we can do is we can write this as x squared minus 5 squared, since 5 squared is 25. And then, using the rule on the left, we can see that that factorizes into x plus 5 multiplied by x minus 5. And finally, example 7. 4x squared minus 9. How can we write this? It hasn't got a middle term in x again, but we can write it as 2x all squared, because 2x times 2x is 4x squared, minus 3 squared. And now, using the difference of two squares, that will become a bracket with 2x plus 3 multiplied by a bracket with 2x minus 3 to complete the factorization.